All right. Hopefully you guys can see me today. I'm very sorry about what happened yesterday. I guess we had some sort of power outage or something at the cable company, or it was intermittent power, and it was basically shutting down. So hopefully, it's been kind of acting weird for the last few days too, so hopefully I will not have a problem today, but we're going to go ahead and give this a shot. And a lot of people are asking if I could just do the same lesson again, so this is a do-over. So what I want to start off with, just like I did yesterday, was what is 0 to the power of 0? And what we have here is this analysis that if you took 0 to the power of 0, does that actually come back to the number 1? Which sounds weird, right? Because, I mean, if I have my calculator on here and I basically play with this, I'm going to basically show that, you know, I'm going to flatten this out so you guys can see it. Okay, so I would show that if I'm going to take 1 to the power of 0, the way I would do this, and just to practice, so let's say you took 2, right, or 0.05 to the power of, what you do is you find the little y, the x with the y on top of it on your calculator if you've got an Apple phone, and you just hit that, and then you do 0.5 to the power of itself, so x to the power of x equals 0.707. Now, what's interesting is that you would expect that as you get with smaller and smaller numbers, so that, you know, 0.5 to the power of 0.5 should be larger than 0.05 to the power of 0.05. And 0.005 should then be smaller, of course, than the power, 0.005 to the power of 0.005 should be smaller than 0.05 to the power. Now, what's interesting is that's not what happens. So if I take 0.005 to the power, and you saw 0.5 to the power of 0.5 was 0.707, 0.005 to the power of 0.005, it gives me 0.97. So I'm actually larger than the 0.707 that was 0.5 to the power of 0.5. And then if I go smaller still, 0.00000, so I've, you know, 5 zeros on here, 5 to the power of 0.00000, right? There's 5 zeros again, 5 equals 0.9999. I mean, that's seems crazy, right? Well, as you get further and further into this, what you'll notice is that actually the number converges on the number 1, so that eventually, right, 0 to the power of 0, right? So, I'm start over again. 0 to the power of 0 comes out to 1. Huh, isn't that amazing? So nothingness comes out to 1, which is everythingness. And to me, that says something a lot about the vacuum and about how there is energy in the vacuum, that there's no such thing as nothingness. In fact, that's just an illusion, that behind the vacuum itself and nothingness is something that becomes the basis, foundational basis for, in fact, everything. Now, I also showed yesterday this cool little thing, which was a gift given to me by Jonathan Leaf. And it's got 7-ness associated with it as well. So there's that hexagon, sorry, not a heptagon, that's basically embedded inside of this. And they kind of look like guitar strings, but they don't play like guitar strings. And what I also wanted to show you, and we'll come back to the 7-ness in a moment, is something related to, and we'll come back to DNA at the end. We're going to come back to the prime number pattern. So this was the prime number pattern, and the prime number pattern obviously relates to 24, and 24 also has a relationship, if you can believe this, to 7, because 7 squared, 49 squared, equals 2401. So it's just 1 past 2400. So there's definitely some relationship between 7-ness and 24-ness. And I was just watching this film this morning also saying that there really probably should be a base 12 numerical system, because base 12, the number 12, has more numbers that divide into it perfectly than the number 10 does. So, you can divide 2 into 12, you can divide 3, 4, 6 into 12. And 24, of course, is 4 times 3 times 2, which is that tetractys of Pythagoras. And so probably there should be 12 numbers, but we have a base 10 system. And I think it's actually for good reason that we do, because we eventually have to learn how to merge those two systems of base 10 and base 12 numbering systems. But the prime number pattern is not only that the red numbers here are prime, and this is just a spiral of 24, so a sine, cosine, and the same as musical notes, 12 notes in a musical octave. So basically what we have here is that, and what I had figured out was that, of course, the prime numbers are known to be multiples of 6 plus and minus 1, and that's why the red numbers are all prime. But what I was more interested in is learning what the green numbers were, which is what we call quasi-prime. And additionally, I wanted to learn what the blue numbers were here. And all these blue numbers were numbers that stuck out to me as being really important, and they matched up with the Tesla 369 as well. So I was more interested in what was non-prime so that I could use it to interpolate what was prime. So for example, this is just, again, 1 through 24, then 48, and then 72, 96, 120, 144, 168, 192, 216. And you may recognize that these numbers are actually the same numbers that showed up on all these blue axes here, the same numbers that showed up on the Da Vinci chart. So you might remember that 216 was there. You might remember that 54 was there. You probably remember also that 36 was there. And all of those numbers are informing the exact angular reference points, like 288 degrees as well, of the pentagon or the decagon. So these are two pentagons that are basically inscribed within a circle. And that's also what Da Vinci was trying to tell us, something with those points. Those also happen to all be musical notes. But you'll also notice here that on this chart, across the blue axes, you have little notations next to all of the numbers that are all mathematical constants or musical notes themselves. So for example, just coming out on the west axis here, so you've got on the x-axis, you've got 18, 42, 66, right? 90, 114, 138, 162, 186. Well, for me, as a number theorist, I'm looking at this going, okay, well, I know that 114 is 1 over pi times 360, so that's a math constant. And 138 relates to the golden angle because this is just rounded to the whole number. 162 relates to phi, which is right next to the golden angle. And that's interesting because, 162 is 161.8. 186 is light speed. 210 is gamma Euler-Mascheroni number. 1 over light speed is 234. 258 relates to Euler minus 2, and 2.58 squared equals the gravitational constant. 282 is the square root of 8, which is a math constant. 306 is the note E. 330 is 1 over omega constant. 354 equals 4 over pi minus 1. And these are all just as divided into 360 degrees, or 432, which is the 6 over 5 Hexa Pentakus relationship to the circle. So if we're on a base 12 system, you could say that we should have 432 degrees in our circle, interestingly. If you look over here, you have 6, 30, 54. That was the angle that Da Vinci gave us. 78 is actually pi over 4. 102 is an Euler relationship. 126 was the other number that Da Vinci put at the top of his page, and it's also the note C. It's a quaternion of 54. And then you've got 150, 174, which is relational to C, or 1 minus C. Then 198 is phi relational. 222 is also phi, because that's 360 degrees. And then basically it just keeps going out, where you can find all these references to musical notes. as well as other mathematical constants. You'll find all the mathematical constants on here as well. Now, Stephen Hawking, the very famous physicist that died not too long ago, said that in order for us to have a unified theory of physics, we first have to have a unification of a few other things, of disciplines within science, in order to accomplish that. One of those things was a understanding of how all the mathematical constants actually work together. Well, I believe here it is, right here on this same chart that gave us the prime number pattern. Now, the reason I was able to use this to predict prime numbers was because I was able to figure out that the green numbers were all divisible by prime numbers that were greater than the number 3. And that by doing so, I could create all the green numbers, and because every number was either prime or one of these green numbers, so red or green, without exception, on these exact columns going out, these spokes all the way out to infinity, then I could create what's called a contradiction algorithm, or derive prime prediction through contradiction. So that means that you basically create all the numbers, you create an exclusion criteria, you can figure out how to make all the green numbers, so you make all the green numbers, and then what's not made but still holds a position in the same spoke must be prime. And that is something we proved. We proved it with supercomputer all the way out to, well past 10 to the 63rd, 10 times 10 to the 63rd power. And it never broke. So the pattern never broke. So we published this, and now I'm happy to say that this particular paper is in peer review with a major journal, and I hope to hear back on it in just a few weeks. So that's that. But to analyze this further, these blue numbers, I actually took this to a whole nother level, which is where we went here. So you may recognize this because this became the foundational basis of something we called Quaternion symmetry. And what I found was that using 1 over x values as well as the x values and placing them around a circle, I took those exact same math constants and plotted them against a wave of expansion going both directions, and at the center, basically separating out. I did it both in decimal based mathematics, or base 10. I also did it in base 12. And so what we found was that this becomes the foundational basis of how DNA is actually made up and how math constants are used in building DNA. We already know that alpha as well as phi and the golden angle, when I say alpha, I mean the golden angle in this context, big A, capital A, is determining the size and the dimensionality of the proportional dimensions of DNA itself. And we're going to talk more about that today, so we'll come back to it. But what I did is I took these numbers and went even a step further and said, okay, these numbers that are in blue here, I want to understand them even more. I want to take it a whole nother level. And so what I did is put them on this chart here. And you can reference them as quaternions, so I call them constant families. And the way you would plot them would be as mirror positions across this 4-quadrant, or the quadrants of a circle. So you imagine this would be a mirror here, the horizontal axis, and the y-axis would be also a mirror. And so you would mirror from here over to here. So 60 degrees mirrors to 300 degrees, and 240 mirrors to 120, and 60 also mirrors to 120 across the horizontal axis. So this would be a whole family, right? And I could say that all of the constants in their 1 over x values also have relationships one to another in this language. Right? And remember, the constants are the verbs, and the more constants we understand, the more we can actually speak a language. We use about 80 math constants today, and probably 5 of them are most fundamental, but we're very limited in our language because, candidly, there must be an infinite number of math constants. There must be. Now, they all return to and come out of and emanate from the number 1, but there must be that number of constants. The other thesis I had was that you have a wave separation here, and this wave separation would basically break, its first break points would be at 0.18 and 0.18 on both sides, and sometimes there's some oscillation variation that comes up in this, because I'd noticed that some of the most fundamental math constants were, 1 over pi is 3,183. So I noticed 318 was very similar to 618, which was very similar to the Euler's 718. I thought, why is it always 18? What's going on with the 18? Well, I started to analyze these numbers, and guess what? I just simply took integers and said, let's start with this exact same analysis here, and here's how we're going to split it up. We're going to do 1,8 and 8,2, 3,2 and 0.68, and 1.5, and so this would be the integer 1, and this would be 0.5 and 1.5, and we do this at integer 2, integer 3, integer 4, integer 5, integer 6, integer 7, integer 8, integer 9, 10. And I also posited that that's not the only way that math constants would manifest. Manifesting of math constants would also happen when 2 turns into 3, when a diagon basically evolves into a triangle, when a triangle evolves into a square, 3, 1, 4, they share one adjacent side. When a square evolves into a pentagon, 4, 1, 5, there should be a math constant that has a value of 4.15. And it's interesting because I was just testing this out just yesterday and just found something that relates to that and sort of supports this notion that there must be a very important constant that has a value of 4.15. And the way I came to it is I basically said, let's take Euler, right? So here's Euler, right? And we're going to square that. And we're going to do this like a Pythagorean, triangle. So a 90-degree triangle. So Euler squared plus pi squared. So that gives us the value of the third side squared. So let's take the square root of that. And of course, these are two very important math constants, Euler and pi, and you would think that they should be able to work around a right triangle, right? So a squared plus b squared equals c squared. So let's solve for c. So then we just take the square root of that, and look at that. It's 4.15, 435. So that's a new constant that must show up somewhere, right, in this work. So now I'm on the hunt for 415 because I know that's going to be an important constant, okay? So, and that's sometimes as simple as it is. Now, there's not, that I know of, there's no math constant that's associated with that value yet. But there must be an infinite number of math constants. So, when I'm dealing with the half step, so the number 1 then goes to 1.5, I can also analyze the integers in the same way. So I break up around them, so it goes 1.68 and 1.32, 1.82, 1.18, and then 1, and then 2. So this would be at the halfway point between integers 1 and 2. So that's kind of the way that I went about this. And what I did is I started off with, integer 1. So you can see I'm actually starting below the number 1. And I even started with negative over here. So negative 0.18 from 0. And then positive 0.18 equals here. Now, 0.18 of 360 degrees is going to give me 6 degrees on the position of 6 degrees on a 360-degree circle. And I already knew that that had a relationship to the constant of light, right? It relates to light speed, right? 1.8 is always going to have a relationship to light speed. 1.8, 1.8, and 8.1, you'll find that too over and over again. So then the next position becomes 0.32, just following the convention I just showed you. And then it goes to 0.5, right here in the middle, which happens to be on the west axis, right? So this is giving me the axis of where these numbers are sitting, right, on the chart as relates to their degree position. So this would then give me a 12 degrees south position for the 0.32, which would be one side of this. So remember, it was 0.5 and then going to 0.32 on both sides of the wave. And then on the other side of the wave, it becomes 0.68, right? And that's giving me a 24 degree position, which, and also an 18 degree position on the west axis. So this is back to this chart. So then I would expect to find, right, for the number 18, it's right here, right? So this is the west axis, this is the north axis, This is the east axis. So you can think of this as a giant legend for this, right? And this is the south axis. So 18 shows up here, but then analyzing the other numbers, are they also going to show up on the other axes of criticality, which are these blue axes, right? And sure enough, they do. So we basically find that the number 30 is right here on the east axis, and as it says right here, 30 degrees shows up on the east axis. So 0.82 becomes the relationship related to that against a circle, okay? So then I can continue to do this, and you'll find that each of these now split up perfectly so that every number shows up at the center of this cross, and it's always relational to 0.18 plus 0.18 negative, and then from 0.5 also 0.18 plus 0.18 negative. Now why is that? Well, because 180 is half of a turn of a circle, and the 0.18 is just a fractal of that half turn. So I did this for all of them, and you'll find that on the axes here of where you can see their degree references, 18, 36, 54, 72, 90, these are all musical notes. So the centers here are all musical notes. So F sharp, D, D, A, D, F sharp, A, C, D, E, F sharp, G sharp, A. In perfect Pythagorean tuning, so you'll see the 216 that's right here. You'll see the 234 and all of that. Then you'll also note that other math constants are coming off on the sides, right, of this, on both sides of this. And they arrange themselves in families. So the Quaternion family of this 0.5 is also 4.5, 5.5, and 9.5, right? And that's why they're all green. So a Quaternion family of this one where the note D is right here is going to be this one, D, A, C, and D again. And all of these match up as families of each other, and they're forming virtually all math constants. And it's fascinating because you could find exactly where they would show up around the circle. And it's beautiful. We actually made a video of this to explain it. And so I'm going to show that to you now. Let me just check to make sure everything is working on the internet today.
Out of the void came one voice, and the one became many. For they knew not their place within the whole symphony, until, under the guiding principles of order, discipline, balance, measure, time, and harmony, the many remembered again their oneness. Could it be that science, hearing the sound of many waters within the seemingly chaotic interference patterns of our reality, has forgotten the art of listening for that one vibration? When circular waves encounter others, they create Vesica Pisces patterns within themselves. And this repetitive dance of duplication actually creates everything we experience in our daily lives. Science tells us it's all nothing but waveforms and mathematical probabilities. But in 2018, Robert Grant compared many of the known math and physical constants against their fractals or inverse decimal and angular values on a circle, expanding upon the study of Quaternion symmetry. Nikola Tesla asserted that the secrets of are embedded in the numbers 3, 6, and 9. And so Grant postulated the hexagonal integer 6 to be the center, the mirror reflection crossover point from which, radiating outward, numbers converge and overlap at various nodes. He hypothesized that numbers both create and emerge out of these wave propagations, and thus all constants manifest at the geometrical intersections between their x and 1 over x representations. The first of these conjunctions occurs at the center where the golden ratio phi and its 1 over x little phi manifest. These are framed by the Euler-Mascheroni constant gamma and its close inverse, the square root of 3. The next conjunctions manifest fractals of pi and the Euler number e. These are framed by the cubed root of gamma and a light speed reference c against e minus 2 and a presently unknown new constant. The next conjunction manifests the squares of phi framed by its square root and the fine structure constant alpha, giving rise to yet another pair of new constants. At the Tesla integers 3 and 9, we find pi and its 1 over x fractal, which reveal 3.1623, a most significant balance between pi and its inverse, producing 2 more brand new constants. Moving further out, each subsequent framing simultaneously converges and diverges like concave and convex lenses, concentrating and dispersing energy. Thus we can see visually how the separation of light and dark is achieved mathematically. And perhaps we begin to understand more fully how the Einsteinian concept itself of space-time emanates from precisely such a dynamic wave function. As already shown, this new understanding predicts that at each halving of a wave, another mirroring constant must inherently result from the convergence. We are therefore able to predict with mathematical certainty when new, presently unknown constants will be found along an infinitely ever-expanding wave. Thus, from a simple x against 1 over x analysis, a unifying mathematical theory emerges, revealing an elegant structure hidden within an age-old mystery. Since all the major constants, pi, phi, e, alpha, appear at these convergences, and presently unknown constants are now geometrically predictable, we see they are all pure Quaternion reflections of the most fundamental constant of all, the integer 1. These findings even suggest that ancient references to a voice of many waters may literally be an accurate metaphor, developing a unique variant of the original Pythagorean tuning, which postulates that true A above middle C should be 432 cycles per second, or hertz. Grant has found that the musical notes themselves emerge from the intersections of these overlapping waves. Their hertz values correspond exactly to their angular relationships on a circle, requiring only minimal equal temperament adjustments to become a viable tuning alternative. And thus we have come, one might say, full circle to the pure, balanced alchemy of science and art, resolving the chaos of the many back into the unity of the one.
Perfect. Okay. So So what's the purpose of all of that analysis? To understand these math constants. Well, these math constants are like the verbs of the universe. They are the verbs that an architect would use to do all of his or her actions, or they, I guess that's the new correctly said term. And I think this is just a very powerful thing. And just as we have 3.14 becomes a constant, I just showed you the value of what should be a new constant that relates directly to Euler and pi. It's the third side of this trinity of the right angle triangle, 415. There will also be, there's another constant at 516 is one of the values as well. And you take 617 is definitely a constant. That's 432, also divided up by 7 times gives us this 61.7. 618 we know is a math constant. That's 5. 718 is a math constant. We know that 819, that 718 is relational to Euler minus 2. So it's the fractal part of it. And 0.718 times 360 equals 258, which is electromagnetism. I taught you already. And if you square it, you get gravity, 6.67408. Then you have 819 would also be a math constant, and 911. So there you've got everything relational again to Euler and pi, which is fascinating, right? Because again, that's pointing us right back to everything that Da Vinci has been showing us as well in his Vitruvian Man, using 4.32 inches as his radius. So with that and that, I've now taught you the concept of Quaternion symmetry. Now, only a few days ago, did I realize that it actually matches as well to trigonometry, and that trigonometry actually has this inherently embedded within it. And that's what was a shocker for me. Now, this particular depiction, this illustration, is basically showing how a circle separates up, and I could look at it. I've done it in both directions. So the top here being 360, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, 165, 180. And then I also did it so that you could arrange it as we would in trigonometry, which is 360 starting here, because I just wanted to see if there were other correspondences. And that's what the bolded, the darker, larger numbers are, just so we can point that out. Now, in trigonometry, the circle goes counterclockwise. So it starts here with 0, and then becomes 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees. And of course, this is separating it out because it's giving me 15-degree increments 24 times. And that's what we just showed you with the 24-hour clock as well. And when I showed you the northern hemisphere of the world, also it had 24 separations of 15 degrees each. And so that led me to posit that our longitude and latitude system is fundamentally based on this 24 as well, which is not a great surprise because the Earth has 24 hours in a day. The sum of angles of that 24-sided polygon that would represent the outer structure of Earth would then have a sum of angles of 3,960 degrees, which equals exactly the radius of the Earth. So it's a genius design. It's a completely genius design, and because everything's related, right? But the thing that really stuck out to me when I did this analysis is I took the sine and cosine and tangent values of each of the positional points of these degree positions in their quaternion position. So for example, a quaternion on this two-dimensional Cartesian coordinate system would be 15 degrees would match, you see this wave line here, this is just like that water having intersecting waves on top of each other that Alan so eloquently took us through, talking about the voice of many waters. This would basically connect to 165 because 15 is actually the same positional point on the circle as 165, which is also just the inverse or backwards version of 195, which is also the same kind of inverse relationship with 345. And you can take one of the quaternions to solve the other side. You just simply add 180 degrees to it, and that shows you where it is. Well, if I take the sine of 15 degrees just by putting it in my calculator, you guys might remember from high school something that we all refer to as SoHCA, which is, easy way to remember that is as follows. Sine x, right, equals the opposite divided by the hypotenuse, right? So if we're going to basically draw out a triangle, right, this is the hypotenuse, so label that. Okay, then I'm going to have an opposite, which let's say this is theta. I'm going to have an opposite side here, opposite, and then adjacent. Now, when I was in high school, I did not love this stuff. And all of a sudden, because it had no meaning to me, now it has absolute meaning to me. And so it was so much easier to learn because it had so much meaning to me. I'm learning this language of the universe. So basically, sine x would be opposite divided by hypotenuse. So if I wanted to find the sine of a value, right, I would then just say opposite divided by hypotenuse is going to give me a value, right? The cos x of that, of theta, would be adjacent, right, divided by the hypotenuse, the lengths of these sides, right? And then the tangent would be the opposite divided by the adjacent. Now what happens, that becomes very bizarre, is that all of the positions, the values, become identical with the exception that they change their polarities. And sometimes sine becomes cosine and cosine becomes sine. So for example, if I take the sine value of 15 degrees, it gives me 0.2588. Its cosine is 0.96592, and its tangent is 0.26794. Now I should have put all this stuff in my paper because this would have been another proof that this is fundamental to both radians and circles. Just as, 2.4 times 1 radian equals the golden angle of 137.5. This is also giving us a similar type relationship where we're seeing here that the sine value, 0.2588, is matching up with the sine value of 165, which is 0.2588. And the cosine value is negative 0.96592. And up here it's positive 0.96592. And then this 0.26794 compares against negative 0.26749. So what's happening is up here you've got, in this quadrant, the values for sine, cosine, and tangent are positive, positive, positive. In this quadrant, they are positive, negative, negative, respectively. Here they are negative, negative, positive, crossing this mirror, and then again, negative, positive, negative. Now what also happens is that you get things flipping back and forth over each of the points of an octagon. So 45 degrees, 135, 180, 210, 270, and 315, and of course 360. The sine value flips to the cosine value, and everything stays positive in this quadrant because these are all positives. So then it becomes positive cosine flips to the positive sine, and then positive tangent flips to positive 1 over the tangent value. So let's test that out. So we just went through sine of 0.2588 and 0.96592. And remember, these are just ratios, right, that are derived through your calculator by plugging them in and just putting the values of the lengths of the sides of a right triangle to create a ratio. And then it has a calculation and it pumps out a number. Okay, and these numbers in 4 poles are all identical. Now when you cross over this middle point here, 45 degrees, something interesting happens because you have sine 0.2588 and its other octonion now, because now we could mirror replicate this 8 times, not just here, 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 and here, but we can actually replicate it here, 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 and here, right? And here. So here and here. So effectively, what happens is that it flips. So the sine value of 0.2588 is now the cosine value of 75 degrees. And the sine value is the same as the cosine value of 15 degrees versus 75 degrees. So it all matches up beautifully. And I was just like stunned when I finally realized this, because I'm like, oh my gosh, I just never done it before. I'd never looked at all the sine cosine values of all the angles of theta in this way before, because I didn't care to. And when I realized it, now I'm like, geez, this proves my thesis about quaternion symmetry, because literally all the numbers are the same. They're all literally coming out of the same thing. And they fall within a categorization after they emerge from the number 1, and then they get mirror reflected in these 8 different positional points around the circle. So fascinating stuff. Now, I can do the same thing down here, but what will happen is I now have these polarity shifts happening. So the sine cosine is moving back and forth as we go down to this quadrant down here. So positive sine becomes negative cosine becomes positive sine, negative tangent becomes minus or negative 1 over tangent, and I think you get the drift, right? So also one thing to remember is anytime you look at a coordinate system on here, x-axis is always the first number, right? And you could place a Cartesian plane on top of this as well, which would just have like 0 at center here. So now we're going to take this from 1 dimension to 2 dimensions to 3 dimensions to 4 dimensions. You can take it all from this same plane, just popping it into different dimensions and applying now areas and volumes, right? And time measurements associated with it. So effectively you have like this axis, this y-axis here would go 1, 2, 3, 4, 5, 6, right? And then negative 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And then negative 1, 2, 3, 4, 5, 6. And this is why you've got positives on this side and negatives on this side. That's why the cosine values here are negatives, because you're down in this side of this Cartesian plane. I wish someone had taught me this like this in school, but you know what? I probably would have been interested anyway, candidly, at that time, at that point of my life. Now, where are we going with all this stuff? Why is it that we're even interested in this stuff? And I just finished this math meeting that we recorded, and at some stage we'll probably edit some of it and put it on, it was a Zoom meeting, and put it on to Facebook and Instagram, so that you could basically see what our math meetings are like and the discussions that we have. And we have about 10 people that participate on this on these calls that we do once a week. Alan Green is one, and I will invite some of them on as individuals also, if I can figure out how to work the new Instagram double feature thing that you can do. And secondly, we have Alan Green, who's a fantastic geometer and mathematician, an expert in math constants as well, I would say. We have Jonathan Leaf, who is a number theorist and particle physicist, and who wrote the book, The Quantum Codex. Alan's also a cryptologist. And we have Talal Ghanem, who is a PhD physicist and a mathematician, number theorist, information theory guy, and the guy that I published most of my papers with. And he is totally genius across so many different levels that then go into physics and optics in particular. We have Adam Apollo is also on that group. Jamie Janiver, who manages kind of all my Instagram and Facebook postings and stuff like that. I mean, I do most of the posts on Instagram. He does probably most of the posts on Facebook. But another fantastic unified theory physicist. And then we have Michael Evans, who is well known for having kind of coined the term the Tryon ray. We have some other guests who are often on there as well, which has been Anthony Morris, who's a number theorist out of the UK. We also have Roman Light out of Australia. And then we have some sort of ad hoc people that I talk to very, very often, whether that's Jane in Australia or Nala Bursi, who's also in Australia. Some others in different, various places around the world. Hopefully I didn't miss anybody else on there, but it's about 10 or so, 12 people that we work with. And it's been fantastic to be able to liaise with them, because the work moves so much faster as we work together. and can share knowledge. And so that's exactly what we do. So I'm going to show you, though, why we're going in this direction. And what's the point, right? What is the point of all of this? And it comes down to, if you go on YouTube, you can find a video called sound, well, I always just type in sound resonance. And this is going to basically show you quickly what we're looking to do. I think you get the basic idea. It's about cymatics. And this is a tone generator. Well, it actually will vibrate this plate according to tones. And you can just download an app on your iPhone. And you pour salt, just like you saw in that demonstration, on this plate. And then you'll play a particular note and certain forms come out of this. Now, there's actually a form that I can still see that's kind of been burned into this, which was interesting because it was 234 hertz. For some reason, that was like causing, that in 468 was causing like the plate to almost reform itself, which was kind of weird. But, you know, you can find here that geometries are created out of these sounds. So geometry is literally frozen sound. And we're looking at it on a two-dimensional plane here, which is creating a standing wave. And that standing wave is what's making the salt move around the field of this standing wave like a marching band. Now, if you have a plate that's round, you'll get different shapes, interestingly enough, because the standing waves will also change. So again, another kind of squaring the circle concept here. And that's really cool work for us, but what it really all comes down to is what is the effect of these frequencies on the human anatomy? Because our DNA is really just numbers, right? All of it. And, you know, once we understand that, we recognize that, well, there's that Hexa Pentakus again, first of all. Everything coming back to the Hexa Pentakus. And you can see here, you've got 5, the adjacent side, 1, 6, 6. So 5, 1, 6, 6. And this is adenine and thymine. and guanine and cytosine. It was funny, somebody posted on Instagram, they said, because I posted this picture, and they said, oh, the angles really aren't like that. They're not really hexagons and pentagons. Well, yes, they are. I guess we live in an age, an era, where people can just kind of throw out whatever they want to throw out. But the fact is that they're truly, well and truly, pentagons and hexagons. And just as bumblebees make hexagons, nature makes hexagons too. The bumblebee is part of nature. What's very interesting is that when you add these up and you add up their protons, adenine will end up with a digital root of 6, and thymine ends up with a digital root of 2. They both combine to 8. Now, the other base pair is guanine and cytosine, which is down here at the bottom, and they add up to, their digital roots are 5 and 3, so they're both adding up to digital root of 8. Now, when you add the phosphate backbone and you take away the combined hydrogen, you end up with always adding up to 9. So that's what this is. So zeros, because 9 is synonymous with 0. In digital root math, there's no 0, right? There's really only just 9. 9 acts like 0 because anytime you add a number to the number 9, 3 plus 9 equals 12, but the digital root of what remains is 3, as if the 9 never existed. 9 plus 8 equals 17, but 1 plus 7 equals 8, as if the 9 wasn't there, right? So 9 has these special properties associated like that. Well, and again, all I did was count up the number of protons. So carbon, hydrogen, nitrogen, right? And then you end up with numbers that basically give us there, and then we add up their phosphate backbones, and then when the molecules bind, what happens to the total number of hydrogens? Are things lost? Are things break off? Whatever. Now, you start off with all 9s with DNA, but then when you unzip this zipper, because it looks like a zipper, and a piece of that DNA comes off and is looking for another pair to line up with, that's through the transfer RNA process, and it combines now with uracil. So thymine is the partner pair of adenine, but now adenine will pair instead with uracil in the transfer RNA, and that's when we get differentiation. Because now uracil has digital root that all of it then adds up. When you combine uracil with it and take away thymine, it literally adds up to 1s and 0s. So these are a true mathematical binary code that then determines the amino acids that get produced, there are 21, which then determine the protein synthesis, which the protein synthesis determines the genotypic expression, whether you have blue eyes or green eyes, or whether you have black eyes or brown eyes, or whether you're tall or you're short, or whether you live long or you live short, or you're susceptible to diseases or you're impervious to them. And this is the area of research that all of this stuff is going towards in life sciences, a movement away from dealing with pharmacologics to get some sort of pharmaceutically induced change at the DNA level to inhibit certain markers that you might have in your genome or to turn others on. And instead, we think we can do it with sound and light. And this has been a dream of mine for over 20 years, that sound and light will be able to help to deal with sicknesses instead of having to use pharmaceuticals in a very targeted way. Because pharmaceuticals often, it's like, you know, when you're a hammer, everything looks like a nail. And so we have this long list every time we listen to some ad in pharmaceutical industry about the list of all of the, you know, side effects. It's kind of ridiculous. It's like shortness of breath, you could die, you know, you could do all this. And then you see this guy swimming in a pool and he looks great and happy. And so you're like, oh, well, that just must be the disclaimer, because we all have to deal with disclaimers. But actually, those are really the list of side effects for drugs. So if we could have side effect less, so without side effect, targeted treatment that's going to be using electroceutical technology, light-based and sound-based technology, we believe that could literally change the whole life science perspective that we have on the world around us. And that's a very exciting thing for us. So not to mention, understanding all of these things, it's almost like, you know, this great puzzle that all of us are trying to solve. And as soon as you solve it, you then can solve things like, oh, now we understand gravity. because everything has to have a mathematical basis. Now we understand electromagnetism. Now we understand how electromagnetism and things like 5G actually interact with the human body. And I can say that there's really been no testing, biological testing, and this is admitted by the industry and their safety pundits as well. There's never been testing on human beings on what exactly that microwave frequency does to human beings. Now, I'm not saying that this is all some giant conspiracy. I actually think that it just wasn't tested, and it was kind of a stupid thing not to have been tested. And I don't believe that the FCC is really monitoring and looking at the biological impacts, because they just think these are all waves that pass through everything, right? And they're harmless waves because they're non-ionizing waves. And ionizing waves are those that can cause cancer. Ultraviolet light, the wrong exposure to ultraviolet light can cause cancer in you. And it can cause cell mutations, but it can also cure you of things like plaque psoriasis. The Egyptians figured out that the cure for people that suffer from psoriasis is to go out in the sun. Get lots of UV light, it clears up your plaque psoriasis. Well, there's just very little understood about the impact of frequency and wavelength on the human anatomy, or on any anatomy, or on the planet itself. What does 5G do to entrain the entire planet? Nobody knows. I would say I'm probably, arguably, because I worked in photonics and I worked in frequency for 25 years, I would be one of the world's experts probably on this kind of science. And I can tell you, in this kind of science I would call quantum biology, I can tell you nobody's doing this. And that's really depressing, because there should be lots of work going on in quantum biology. And there just isn't. And so we're trying to change that. So I've come up right up on the hour. I hope everyone was able to see this fine today. Again, apologies for yesterday's snafu with the whole... I was amazed that you guys stayed on for as long as you did, because I didn't even know that the screen was frozen. And of course, that's the thing with these systems. Unless you're reading the comments, which is kind of hard to be able to read the comments while you're teaching complex stuff like this. So thank you for your patience. Everyone have a wonderful day. Have a great weekend. We'll come back to class again I think I'll do class again on Monday. So we'll take a break over the weekend, and I'll see you guys on Monday. Have a great weekend, everyone. All the best.